Okay, last video here, we're going to introduce something new, okay, and this is going to be stretches and compressions. Now, what do stretches and compressions do? Well, let's say that we start with a parent function of our absolute value, okay, so there's our parent function. We can stretch this, and when I stretch this, it can become thinner, like this. I can also flatten, or sorry, I can also compress this, my bad, which would end up making it look flatter. Okay, so your stretches are going to stretch these things out and make them look narrower. Your compressions are going to flatten them out and make them look flatter. Okay, so let's start with how do we handle these here? Well, first, I've got the y equals 1/2 the absolute value of x plus 3. So the first thing that I need to do, and I didn't mention this earlier, but we need to be labeling our graphs up above this. Okay, so the first thing I'm going to do is I'm going to graph my parent function with this. Okay, so my absolute value has your 5 points. And remember, absolute value makes a V shape. Okay, so there is my absolute value function. Now, the next thing that I need to graph is this 1/2 x. When we multiply by a number, whether it be a fraction or whether it be a whole number, it is going to cause these graphs to stretch or compress. Any value that is greater than 1 is going to make it stretch, okay? And any value that is between 0 and 1 is going to make it compress. So this here is going to be a compression for us. Now, to figure out how to make this expression, I always use a chart. The x values that I use for my chart are going to be back from my previous slide, those x values. So the x values from the previous slide are -2, -1, 0, 1, and 2. Okay? Now, I'm going to plug these x values into that equation up there. So I will have y equals 1/2 absolute value of -2. So y equals 1/2 times the absolute value of -2. Well, that's just going to be 1/2 times 2, because the absolute value of the absolute value of -2 is just 2. 1/2 times 2 is 1. So instead of having the point -2, 2, I have the point -2, 1. Okay, and I'm going to repeat the same process, but now I'm going to do the absolute value of -1. Okay, so -1, absolute value of -1 is just 1. What is 1/2 times 1? Well, that is 1/2. So now I've got -1, 1/2. Okay, and I just keep repeating this process. So I would have next 0 plugged in. Absolute value of 0 is just 0. 1/2 times 0 is 0. Okay, and keep in mind, where did I get these x values from? We always get them from the previous graph. What are the x values of the previous graph? So we looked at the graph before, and we got the x values from that graph before. Okay, 1/2 times 0 gives me 0. And then I go back in and I plug in a 1 and a 2. Well, we know that this graph is symmetric, so that means 1 and 1/2 and 2 and, 1. Okay, so you guys can see that this has compressed. I've flattened this thing out. Okay, oh my gosh, that was awful on that point. There we go. Apologize for that. So that is how I've handled my compression for that 1/2. Then the last thing I have is that plus 3. So y equals 1/2 absolute value of x plus 3. Same rules apply. That is on the outside. So everything is going to shift up 3 spots. So all those points move up 3. And there we go. So this one was a compression because it was 1/2, so it ended up making it flatter. We're going to do a couple more examples with this. This table, though, is the key, and you always want to look back at the previous graph. Okay, so next, I've got y equals 2 square root of x plus 3. So start out with my parent function, which is just the y equals square root of x. 0, 0, 1, 1, 4, 2. Remember, this is just that little nub in there. Okay, now I always want to work inside out. So the next thing that I want to do would be my square root of x plus 3. Square root of x plus 3. Plus 3 makes me think I need to go to the right. But remember, if we're in prison, we always do the opposite. So this actually goes to the left 3 spots. And then we have our square root function here. Okay, I need to make a chart. My x and y values. What x values do I use? Look back at the previous graph. So -3, -2, and 1 are going to be the x values that I use. Okay, so I've got y equals 2 times the square root of x plus 3. So that's y equals 2 square root of x, which in this case is -1, or -3, sorry. -3 plus 1. Okay? -3 plus 3. Geez, I was looking at, sorry, pause for a sec. I couldn't figure out what I was doing wrong. Okay, so 2 square root of x plus 3. Okay, so what I plug in for x for my first one, I plugged in that -3. That gives me 2 square root of 0. Square root of 0 is just 0. 2 times 0 is 0. So -3 stays right there. Next one I'm going to do, instead of a -3 in there, remember I'm looking back at my previous graph, now I'm going to do a -2. What is -2 plus 3? Well, that would give me a positive 1. Square root of 1 is just 1. 2 times 1 is 2. So -2, 2 is on this graph. Okay, and then finally, I'm going to plug in a 1. 1 plus 3 is 4. Square root of 4 is 2. So 2 times 2 is 4. So 1, 4 is on this graph. Okay, so again, things to remember when you were doing your stretches and compressions. How did I find these x values here? Well, remember, the x values that you use are always back from that previous graph. So look back at the previous graph's x values, and then you plug those in to that equation to figure out what it looks like. One more example that I want to show you guys. Okay, I've got y equals -2x squared. Okay, this one start out with is just y equals x squared. So this is our parabola. 1, 1, 2, 4, -1, 1, -2, 4. Okay, now when I do this one here, a lot of people look at this and only see one shift. There is actually 2 shifts going on here. First, we would have y equals 2x squared. And then our last shift would be y equals -2x squared. So that negative and that 2, they do 2 different things. So we would want to separate those. Okay, now I do want to show you guys one thing that a student did last year that I kind of liked, and this might help make sense for you here. My student last year, when she would look back at the previous graph, she would write out her points. So she would say x and y. She would list them all. So you'd have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then after she listed all those points out, that 2 out in front, to figure out her next points, just meant that she had to multiply all of the y values by 2. It was going to stretch those y values by 2. Okay, so she still looked back at her previous graph, but instead of doing just the x value, she went ahead and wrote the y values too, and then multiplied all of them by 2. Okay, if you guys look back up at this here, you can see that you could do that as well with these. We had -3, 0. What is 0 times 2? What is 0? Okay, we had -2, 1. What is 1 times 2? 2. We had 1, 2. What is 2 times 2? 4. So that same procedure can be used for that. It's totally what makes the most sense to you guys. Okay, but so here, looking at those, we've got -2, 8. We've got -1, 2. We've got 0 and 0. 1, 2, and 2, 8. And then last, we've got this negative. Negatives make things flip. Is that on the inside or the outside? Well, that would be on the outside because remember, it's outside of the parentheses. So all these points flip vertically, and our parabola ends up looking like this here. Okay, And basically, this lesson is just a review from last year. The one new piece of information is the stretches and the compressions. And we will make sure on your guys' worksheet that you have plenty of those to practice.